Hello everyone, today's topic is types of matrices. This is a topic from linear algebra and here I am going to discuss about the types of matrices through some examples. And also if you haven't subscribed my channel yet, then quickly subscribe for getting latest updates. So let us get back to our topic, that is type of matrices. So the first type of matrix is the diagonal matrix. Now here Aij is equals to 0 whenever I is not equals to j. This means that if we take a 3 cross 3 matrix, okay, then here the elements are represented by A1, 1, 1, 2, 1, 3 like this, okay. So here the first element is represented by I and the second element is represented by j, okay. So this one that is A12, A13, these all will be 0 and A11, A22, A33, these all will be non-zero, okay. So this type of matrix is called a diagonal matrix. For example, here this is 1, 0, 0, 0, 2, 0, 0, 0, 3. This is an example of diagonal matrix, okay. Now our next matrix is lower triangular matrix. Now lower triangular matrix, here what happens that Aij is equals to 0 whenever I is less than j, okay. For example, 1, 0, 0, 2, 4, 0 and this is 3, 6, 8. Alright, so here what we can see that the lower triangular elements are all non-zero, okay. So therefore this is called lower triangular matrix. And here see I is less than 0, Aij is 0 for I less than j. That means see this element is what, A12, this element is A13, alright, and this element is what, A23, alright. So here in all these three cases, see I is less than j. This is I and this is j, okay. So I is less than j here also, and here also, okay. So these elements are 0. Therefore this is a lower triangular matrix, alright. So the next type of matrix is upper triangular, okay. So upper triangular matrix, here what happens that Aij is equals to 0 whenever I is greater than j, okay. For example, see if I take a 3 cross 3 matrix, okay, this is a 3 cross 3 matrix and let us take the elements say 1, 4, 2, 0, 3, 6 and this is 0, 0, 8. Alright, so here see the upper triangular elements will be non-zero. So therefore this is called an upper triangular matrix, okay. So here see this element is what, A11, this is A12, this is A13, this one is A22, this one is A23 and this one is A33, okay. So here for I greater than j, Aij will be 0. So see this one is A21, this is A31 and this one is A32. In all these three cases I is greater than j, okay. So therefore these are 0 and these are non-zero, okay. So therefore this is an upper triangular matrix. Now next let us come to the unit triangular matrix, okay. So here a unit triangular matrix is a lower or upper triangular matrix in which each diagonal entry is 1, okay. Means any lower or upper triangular matrix whose diagonal entries are 1 is known as a unit triangular matrix. For example, see this, if this is 1, 2, 3, then this is 0, 1, 6 and this is 0, 0, 1. So this is what, an upper triangular matrix and here the diagonal elements are 1. So this is known as an unit upper triangular matrix, okay. So this is its example. Now next let us come to identity matrix. Identity matrix is what? Say this 1 0 0 1. This is a 2 cross 2 identity matrix. Again 1 0 0 0 1 0, and this is 0 0 1 is a 3 cross 3 identity matrix. Here what happens, only the diagonal entries are 1 and rest all the entries are 0. Okay, see, so this type of matrices are called your identity matrix. Okay, so the next type of matrix is a scalar matrix. Okay, so a scalar matrix is a scalar multiple of the identity matrix. So if this is a 2 cross 2 identity matrix, then its scalar multiple is known as the scalar matrix. Okay, so here 2 0 0 2, this is known as the scalar matrix. Okay, so next let us see the transpose of A. The transpose of A is denoted by AT, and here is the P cross M matrix whose ij entry is the ji entry of A. P cross M. So let us take a 2 cross 2 matrix. Say A is equals to 1 2 3 4. Okay, this is a 2 cross 2 matrix. Then A transpose will be equal to 1 3, that is this column becomes a row over here, and the next column will become the next row over here. Okay, so that is the columns converts to rows. Okay, so this is called transpose. Next, now the next type of matrix is symmetric matrix. Okay, so a square matrix A is said to be symmetric if A transpose is equals to A, and skew symmetrics if A transpose is equals to minus A. Okay, so let me explain this through an example. So let A be equals to 0 1 minus 2, and this is minus 1 0 3, and this is 2 minus 3 0. Okay, then A transpose is equals to 0 minus 1 2, 1 0 minus 3, and minus 2 3 0. Alright, now we can see that this is equals to minus of A. Okay, see, if you multiply 1 minus over here or take minus common from here, then this will become A, isn't it? So therefore this is equals to minus A, hence this is a skew symmetric matrix. Okay, now the next type of matrix is Hermitian matrix. Okay, so when F is equals to C, that is when A has complex entries, then the Hermitian adjoint of A is its conjugate transpose. Okay, so conjugate of C, if any number say A plus IB belongs to C, okay, that is the complex number, then its conjugate is given by what? Let Z be equals to A plus IB. Okay, so this is a complex number, then Z conjugate is equals to A minus IB, isn't it? So the transpose of conjugate is said to be the Hermitian adjoint. Alright, now a square matrix A is said to be Hermitian if A star is equals to A. This is actually A star is equals to A. Alright, so let me explain this through an example. Say if A is equals to A, this is C minus ID, and this one is C plus ID, and this is B, then A conjugate transpose is equals to, see here A star is equals to A conjugate transpose. Okay, so A conjugate transpose, that is equals to A star, is equals to what? Say this is A C plus ID, this one is C minus ID, and this is B. Alright, its transpose. So its transpose is equals to A C minus ID, and this is C plus ID B. Okay, so this is equals to what? A. Hence, here A star is equals to A. Therefore, this is a Hermitian matrix. Okay. Now, next let us see skew Hermitian matrix. Matrix is said to be a skew Hermitian matrix if A star is equals to minus A. Alright. If A star is equals to minus A, then we say A to be a skew Hermitian matrix. Okay. Now let me explain this through an example. Okay, if A is equals to 0, minus 2 minus 3i, and this one is 2 minus 3i, 0. Okay, then A star is equals to, that is a conjugate transpose. A conjugate transpose is equals to, this is how much, 0 minus 2 plus 3i, and this is 2 plus 3i, 0. Okay, and its transpose is equals to 0, 2 plus 3i, and this is minus 2 plus 3i, 0. Alright, so this is equals to what? Minus of A, isn't it? So therefore this is a skew Hermitian matrix, as A star is equals to minus of A. Okay, so therefore this is a skew Hermitian matrix. Now next let us come to the unitary matrix. A square matrix is said to be unitary matrix if A into A star is equals to I, which is equals to A star into A. That means whether you do A star into A or you do A into A star, if this is equals to I, that is the identity matrix, then this is called the unitary matrix. Okay. Next matrix is idempotent matrix. A matrix is said to be idempotent if A square is equals to A. Okay. If A square is equals to A, then the matrix A is called the idempotent matrix. Okay. So let us take an example. Say, let A be an identity matrix 1 0 0 1. Okay. Then A square is equals to 1 0 0 1 into 1 0 0 1, which is equals to what? First row into first column, that is 1. Again first row into second column, that is 0. Second row into first column, that is 0. And then second row into second column, that is 1. Alright, so this is equals to A. Hence this is a idempotent matrix because A square is equals to A. Okay. So now the next matrix is nilpotent matrix. A square matrix is said to be nilpotent if A to the power n is equals to 0, where n is any positive integer. Okay. For example, see, if we take A is equals to 0 1 0 0, alright, then A square is equals to how much? 0 1 0 0 into 0 1 0 0, which is equals to first row first column 0, first row second column 0. So, okay, and this is again 0 0. So see what we are getting, 0. So therefore this is a nilpotent matrix. Okay.
Thanks for watching this video, and please do like, share and subscribe my channel if you like this video. Thank you.